Hello, grade 6 teachers. Let's have a look at some ways that you can connect computer sciences into your matter unit. The computer sciences organizing idea all the way from kindergarten through grade 6 has to do with creativity, design thinking, and computational thinking. By the time students come to grade 6, there are a lot of learning outcomes they are expected to have learned along the way. One nice thing about the computer sciences curriculum is that in the early grades, it's talking a lot about interpreting, following, and creating instructions, which is something that students have been doing ever since they could learn to talk and walk. So even though we haven't been maybe explicitly connecting that into computational thinking and algorithm design, students are familiar with instructions and how they need to be followed in a particular order. So just by making connections to things that we do even just throughout our days as classroom routines and talking about how we as humans follow instructions in the same way that we can teach a computer or a machine to follow instructions by breaking whatever our outcome is down into the basic steps and putting them in a logical order. We are creating an instruction that could be followed by a human or a machine, which is teaching our students that computer science overarching idea and moving them towards the computer programming they're expected to be doing by grade 6. The grade 6 curriculum talks a lot about abstraction, which is really high level thinking. And at the base of it, it's talking about just breaking something down into its simplest parts. And we'll have been doing a lot of abstracting in the lower grades in computer sciences, but we haven't been talking about what it is explicitly with the students and asking them to identify it as they're using it and areas that it may be used. So there's a lot of knowledge around what abstraction is to help you teach your students what that means to break something down and only focus on the most important parts to make something into its simplest form. And we can apply this easily into not only the matter unit in science, but all of our other science topics, as well as bring it into math and language arts and social, where we see areas that it can be applied. So just some more knowledge within the same understanding all around abstraction. And in grade 6, we're really evaluating technologies and starting to look at the larger role of technology in society. So we're going to be doing more explicit teaching of computer science, and some of the connections that we're making are going to be a little bit less explicit to what we have for skills and procedures in grade 6. Creativity starts early on in the computer science curriculum. We're really just asking students to apply creative thinking, to think of new ways to reach the same solution, looking for different paths to get to the same outcome. Using the design thinking process starts explicitly in grade 4 for your students. Design thinking is tricky for kids, particularly learning how to put yourself in someone else's shoes. And then as we get to the end piece where students are asked to test and then, loop through and go back and fix or redesign or debug, that is really hard for children, students, even some adults to do. So just learning to fail and go back and try again and continue that loop until we reach success is a really key piece of the design thinking process that you're going to want to expose your students to and help push them through as often as you can find the opportunity to do so. And then computational thinking, students learned this explicitly in grade 3, but again, the gaps will be there for those that didn't get the computer sciences in the lower grades. Also, it's a big concept that the more often we're incorporating it, referring to it, using the language, we're just going to cement that knowledge for the students. So let's have a look at an activity that students can do in Scratch animation that would meet this skills and procedures, or both of these skills and procedures, about phases of matter. So we'll be meeting these skills as well as hitting the computer science skill about using a block-based coding language through the Scratch platform. Also, this is covering some grade 4 and grade 5 computer science understandings as well. So again, bridging those gaps, giving students that sort of background knowledge. We're asking them by grade 4 to start building things with a block-based coding language, creating computational artifacts, working through computational thinking, because that is an absolute necessity when we're building algorithms in a programming language. So we're hitting lots of things with this activity. I have a Scratch template developed that has all of the sprites included already. So the water molecule and the buttons and the slider are all there, but none of the code is included. So then the Scratch cards that are the second link here, you can give to your students. They are going to explicitly show the blocks of code and any extra steps that are involved. So when we're creating variables, for example, the instructions are included for that. So you can have your students take those slides, take the template, and start just building this code from scratch, working together, having conversations about what the code is doing in relation to the particle model. We're going to be meeting these computer science outcomes, also learning a lot about how molecules move around and how temperature affects that state. You could give the students a template. If they're already Scratch aficionados, you use it with them all the time. Maybe they've been using it in lower grades. You could just show them the example and see how they do coming up with that on their own. Creating the project completely from scratch in Scratch would really meet the computer science outcomes, have students working through that design thinking process, definitely looping through testing and debugging, and then really getting close and personal with the computational thinking process too. So again, just based on level of comfort, template, slides, it's all there, hands-on and guided. You can also give students as much choice as you like. Canva is a great place for creating sprites and backdrops if your students have access to it and are familiar with it. That's where I create most of my graphics for my Scratch projects from. We could also, same things you're seeing here when we're starting to talk about the liquid thermometer. So we're talking about a physical piece of equipment. That doesn't mean that we can't still be applying in the computational thinking and design thinking skills. And I have another Scratch project that's going to cover the second skill about just relating the states of water to temperature. So the previous model we did actually also did that, but this is a simpler one where students, I would highly encourage you to have students, especially if they completed the previous model, to do this one maybe without using the template. With that said, the template is available. Same thing, Scratch template with just the sprites, waiting for the students to enter the code. All of the code is included on the Scratch cards, so students can just take that and build it. If you have them build from scratch and determine how these movements are going to happen as the temperature changes, they're really going to be showing you that they know block-based coding. They can create a computational artifact. They can work through those two design and computational thinking processes. And they're also really going to show you that they understand that concept about what happens to water at the different temperatures as related here. So less specific to coding and computational thinking, as we're looking at some of the other skills and procedures in this unit and also in any other units that you're covering, whether it be science or some of your other subjects. If you're asking students to create some type of a project or a tool in this case, we're definitely going to be asking them to work through some of that design process. So we can get into the beginning, what is our goal? Well, we want to make a tool that measures temperature. Well, what do we know about liquids and temperature. What do you know from the project we just did about water? And we're having these discussions. We start to brainstorm. Well, what do you think you could, how could you, use what you know about how liquids expand and contract to make something that's going to tell you what the temperature is. We'll do the brainstorming. And then obviously we're going to move into, the prototype, build something, testing it, evaluating it. So doing this project is 100% going to connect into the design thinking piece, which is coming out of our computer sciences, naturally related right into something we're doing. Ask students to create the instructions, repeat the instructions, and we're also connecting into that computational thinking. If we can take this beyond into even further computational thinking, we have a specific skill in your CS that talks about abstraction. Mentioned earlier that abstraction is a huge piece of the grade 6 CS curriculum. So if we can think about our tool and have some conversations about, well, what kind of material does it need to be out of? And will this type of material work? And why not? And are there alternative materials that you could use? And how do you think those alternative materials would work? And maybe we start to talk about some of the properties of those materials. Like, for example, if it's absorbent, it's not going to work probably as a temperature measuring device with a liquid in it. So again, just involving those conversations, breaking it down, talking about those specific attributes of the materials. We are decomposing, we're abstracting, and then by creating a process for coming up, could you create instructions so some other person or a machine could build your tool? Now I'm going to create an algorithm. I've learned about measurement tools, and I've also learned about computer sciences by doing these activities together. Anytime we're doing an investigation, an experiment, we're going to be incorporating design thinking and computational thinking, depending on how much the students are asked to create on their own, come up with a solution on their own, then we're really in that design thinking world. If we're looking at something that's provided and we're breaking it down and we're analyzing it, then we're probably more in that computational thinking world. But either way, we are connecting that computer science piece in. If we are focusing on the simplest, looking at one part because we're only care about that attribute, we're applying that abstraction. And then always just keeping in mind, our students are coming into new curriculum. They haven't necessarily had it in the previous grades. We're going to be bridging a lot of gaps with the computer sciences. If you can just connect that language to following instructions. Students, I gave you an algorithm for what to do when the lunch bell goes. What is it? You guys are like my robots, just like we program the robots we have in the classroom, or just like we can program the cat in Scratch. If I give you a set of instructions, you memorize it, you know it, you always complete them in this order. I have programmed you in the same way we program a machine. So just making those references to how sets of instructions, whether they're followed by humans or followed by machines, we're working through computational thinking, and we're really learning how we can code computers. So those are some ways that you can connect computer sciences into your Matter unit and also into your just daily routines and other teachings. I hope you enjoyed.